So before we begin this lesson, make sure you go over and print off the documents for this week. What we're going to be looking at right now with this lesson is the one labeled Partitioning Holes. And then out of the other set, we're looking at the one that is titled Fraction Sense or something like that. So developing fraction sense, it starts with Exploration 5.8. So we're still reviewing fractions from the class before this one. So fractions are always the part I have or want on top over the parts of the whole. Okay, it can be easier for us to generalize with a statement like this. So the bottom denominator is always representative of parts of the whole. The numerator is always representative of parts I have or parts I want. So let's take a look at the worksheet packet more like, that says Exploration 5.7 Partitioning Holes. So we're just going to do some of this, but I want to kind of look at this. So we don't have a textbook for this class, so I just kind of pull information that I really like. And so notice these are the model types we talked about last time, right? Area models is where you're splitting up one piece into multiple things. So not only do they give us kind of some examples of things we could draw, like circles and squares, and then we could split those shapes up accordingly, but also some manipulatives, okay, pattern blocks you should have already gotten for yourself, right? And then geoboards, we haven't talked about that, and we probably won't too much in here, but if you know what a geoboard is, you can use that for area models as well. For discrete models, by the way, this is what this book calls set models. So discrete just means something that's countable. So notice, remember, a set model was like a set of items. So we already talked about some classroom easy things you could find in your classroom to use for this, right? Like paper clips, like coins, like candy pieces, any of that. And then lastly was the number line model, which we used C-rods to discuss that. You could also talk about a number line or various things. All right, so I want to look at just a few of these. We're going to kind of do some scattered questions. So I want to look at some examples of area models and then maybe talk about when we draw them, what will be preferable. Okay, so if we were to try to draw this rectangle or partition or split this rectangle into two pieces, notice we could go this way, right? Now, my picture's not perfect, right? But this would be two equal pieces, right? So each of these would be 1/2. But it would be just as correct to split it horizontally and say this is 1/2 and this is 1/2. Okay. Let's skip down to C. So if we wanted to do 8 pieces, notice doing 8 little strips is a little tedious. So that's 3, 4, 5, 6, 7, and 8. Okay, but notice if I have a picture that's too small to label, I can do something like this. Each of these is 1/8. But notice I could also partition up this rectangle like this as well, right? I wouldn't have to stick with just horizontal or just vertically. And notice each of these pieces represents 1/8. So we're going to find that rectangles are one of our kind of go-to shapes for partitioning or splitting things up, or for using the area model, because the rectangles are so easy to draw and easy to split up. Okay, and maybe you'll see that if you try for yourself to do something like a triangle here. Okay, notice a triangle, of course, the easiest way would be to split it down the middle. Okay, but don't forget, you'll probably have some creative students, so never count an answer wrong just because it's not one that you thought of. Okay, as long as it's correct. Now, I know this isn't perfect, but technically, these are both 1/2. Although I like the second one better. It's a much more creative answer, right? And admittedly, these little notches should be the same size, but again, I'm no artist. Okay, so let's focus kind of on some rectangles. So we kind of already practiced this with pattern blocks, but I want to make sure that we know how to draw it. Maybe if we don't want to get out the pattern blocks in our classroom, because that's going to happen. So notice this rectangle has a value of 1/3. So I'm going to show this as 1/3. Okay, and if I want to show 1, I need 2 more thirds, basically. So when I attach these, I do my best to make sure these pieces are the same size, because remember that's one of the foundations of fractions. We have to have equal pieces. And then in the end, let's make sure we label and say, okay, this is 3/3 or 1. But what about when we get to B or maybe C? Those are a little tougher questions. Okay, so the same size rectangle, now I'm saying that it represents 3/4. Okay, so using our little explanation of fractions, remember this number down here represents the pieces of a whole. I can't spell pieces apparently. And this represents the pieces I have, or the parts I have. So I have 3 parts. So I'm going to split this into 3, right? I'm going to start using a pen. I don't think that pencil's dark enough. So each of these, this is really tiny, so I don't want to fit it in. Each of these is 1/4. So then if I have 3/4, I just need 1 more fourth to get to 4/4, right? And notice, still, I would want you to say something like the total is 4/4 or 1. So what about in part C? If the rectangle has a value of 1 1/3, show 1. Okay, first thing is this is higher than 1, right? So we know that 1, or we should know that 1 is going to be smaller than what we started with. Okay, so first we probably need to change this into an improper fraction. So bottom times the whole number plus this number, right? 1 1/3, another way to say that is 4/3. Okay, so this is the parts to the whole. And this is the pieces I have, or the parts I have, I should say. So in other words, I actually have 4 pieces right now. Notice each of these represents what? Each represents 1/3 for a total of 4/3. But if I want to go back to 1, I only need 3/3, so maybe I could use my pencil or a colored pencil or something to shade this in. Okay, so in the end, the shaded area is 3/3 or 1. So if you'll keep in mind that trick I told you about the fractions, what the numerator represents versus what the denominator represents, I think it'll make doing most of the things in this packet a lot easier. All right, so let's kind of turn the page. And let's practice a few of these. Now, I probably wouldn't suggest using hexagons for my pattern or my area model if I were drawing them, right? Hexagons are nice when you have the pattern blocks, but they're tougher to draw, admittedly. So notice if you have this, right? And again, this is the parts I have. And this is the parts to a whole. Okay, so this piece is 1/3 and so is this. So if I want a whole, I need another little half hexagon. In other words, another little trapezoid there. Okay, and then notice at the end I would want you to label it something like this. The total is still 3/3 or 1. Okay, so we're not going to do all of these, but let's look at maybe part C. Okay, I think it can be a little challenging, but we always want to vary what our whole is. It can be more challenging though when the whole is, you know, 2 shapes together. So if the 2 hexagons together have a value of 4/3, okay, so not to sound redundant, but again, this is the parts I have, and this is the parts of a whole. In other words, a part that makes 1. So I need to split this 2-part shape into 4 pieces. Notice that's actually not so bad to do. That would do it, right? Because each of these would be 1/3 for a total of 4/3, right? So if all I want is 3/3, again, I can use shading. So I only want 3 of these guys. So in the end, The shaded region is 3/3 or 1. Okay, so I think it's pretty clear maybe why we like the area model, why we like to use rectangles. So let's go ahead, what we didn't talk any about last time was how to look at set models. So let's look at the very back page in that packet. So if the diagram has a value of 2/3, we're supposed to show 1. But our strategy is going to be the same. This is still the parts I have, but in this case this is going to be the groups that I have, and this is still the parts to a whole. Okay. So I have 2 groups, so how can I split these dots into 2 groups? It looks like this way would work, right? And then I would want you to label, this is a third and this is a third. So if I want to have 1, right, how many more thirds do I need? I need 1 more group, right? So I'm going to draw for myself a third group. And then in the end, all of these total up to 3/3 or 1. Okay, same strategy here. You just have to pay attention. If the given diagram has a value of 1, show 3/4. Okay, so how maybe could I rewrite 1 so that I could more easily show 3/4? I could rewrite 1 as 4/4. In other words, I have 4 groups. So this one's kind of tight, so I would probably say each of these is 1/4 or something. So if each of those little subgroups that I circled is 1/4, then if I want 3/4, notice I don't have to, collect those dots in the same fashion. I can make them a little more organized if I want. So 3/4 would be this whole set. Okay, notice I'm labeling the whole set, but I'm also labeling like this little subgroups. Okay, so let's look at part C. If the given diagram has a value of 2 2/3, then show 1. Okay, so probably we would want to change this again into an improper fraction. So think of 3 times 2 plus 2, so that would be 8/3. Okay, so again, this is the parts I have, right, and this is the parts to a whole. So I need to split this into really 8 parts, right? So it looks like this would be a fairly easy way to do that. So each of these represents what? There's 8 of them, and they are each representative of thirds. So if I want 1, right, that means I want 3/3. So how many little groups do I need? I need 1, 2, 3. So remember we talked about this the first week, that this course is some content but a lot of how you're going to teach these types of topics. So notice I'm being really careful here, right? So the 3/3 is the whole group and I'm labeling each little subgroup and everything else. Okay, so really try to do that. All right, so for the last one we're going to look at was set model. Let's look at part D. If the given diagram has a value of 1/3, show 1/2. So notice the parts I have is only 1, right? So that means this is 1/3, but the question is, how do I go from a third to a half? Okay, so I gave you a suggestion during last week's lectures that you always want to try to relate it to the whole when possible. In other words, we're not going to jump straight from 1/3 to 1/2. We're going to try to relate it to the next whole number, which is 1, and then we'll go from there, right? So how would I make this equal to 1? Well, I would need 2 more sets of 1/3. Okay, notice the total here is 1. The total is 3/3 or 1. Okay, notice that gives me 12 dots. So now I'm going to move over here and I'm going to kind of redraw these. Okay, so I still have 12 dots. Let me make those a little darker. They're not really showing up too well on this camera. So all I did was kind of transfer, right? So this is still 1. But now I want to have 1/2, right? So I want to split this group into 2 equal pieces. So I'm going to use kind of a different color here and even a different shape to kind of partition it off. So if I did that, notice I'll have 1/2 and 1/2, right? So in the end, always make sure you answer the question. So I'm going to put a star by this. So in the end, 1/2 would actually be 6 dots. Okay. But if all you did is this on a test, I'm going to count off for that. I want to see your thought process, how you thought to change. Well, I need to go from 1/3 to 1. Then I need to take that 1 and split it into 2 pieces. And then finally my answer would just be that 1/2 of that set would be 6 dots. So I know there's some things in this packet we didn't go over. That's I'm always usually going to give you more than we really have time to look at so that you have kind of extra stuff that you can look at if you want. So let's talk about how, and I've already mentioned kind of some of this, but how are we going to draw the different models when maybe we don't have our manipulatives out, or we don't want to get our manipulatives out? Because admittedly, when you're teaching, there may be some days or just some groups of students that, you know, maybe getting out the manipulatives is a little more trouble than it's worth. Okay, or maybe you don't have manipulatives. Sorry about that. Let me move that back down. All right, so I already kind of touched on this, but when you want to talk about the area model and you're drawing them, I want you to use rectangles. Could we use circles or triangles or hexagons? Absolutely, but the easiest thing to draw and split up, which is what the word partition means, okay? The easiest shape to split up is going to be a rectangle, no doubt. Okay, when we want to refer to the set model and maybe we don't want to get out our candy pieces or our paper clips or our coins or whatever, we're going to use dots or circles. They're really quick to draw. Okay, so if I was trying to show 1/3 here, this might be an example of how I would do that. And then I would say each of these is 1/3, right? For a total of 3/3 or 1. Up here I forgot to label that, right? But we should actually say the same thing. The total is 3/3 or 1. And then for the line model, when we don't have our C-rods, or maybe we don't want to get them out, we can just use a number line. The nice part about the number line is you don't really have to talk about what your total is because the number line already shows that. So if you had a number line like so, and I told you that this was the unit 1, right, the distance from 0 to 1, and I asked you to split this up into thirds, you would split it up into 3 equal size pieces, right? So this would be 1/3 and 2/3. It's probably good to go ahead and say that 1 is 3/3 there. Okay, so notice when I'm talking about values on the number line, I go ahead and count up. But if I'm talking about distance, this is 1/3, this distance is also 1/3, and this distance is also 1/3. Okay, the bottom numbers are more talking about location on the number line, so that's kind of a difference. Okay, so let's talk about how we can maybe discuss fractions just in general terms. So in general, when you increase the size of the denominator, then you'll make more pieces to the whole. But when you do that, the pieces will be smaller in value. So think about a pizza. If you split a pizza into 2 pieces, those pieces are fairly large, right? If you try to split the pizza into, say, 10 pieces, those pieces, although there'll be more of them, there will be less large, right? The values will be less. And something else that's true is that the bigger the denominator, the smaller the fraction, as long as the numerators are the same. I hear this phrase out there all the time. It's kind of a go-to with fractions. So I heard teachers say all the time, the bigger the denominator, the smaller the fraction. And that's certainly true. Just make sure that you put the disclaimer that the numerators have to be the same. In other words, you have to be talking about the same number of pieces. And as long as you are, then yes, if you increase the denominator, then the pieces will be of smaller size. That's basically what we're saying. Okay, so let's look at an example of this. So let's say that I want you to rank these from smallest to largest. And I don't want you to get out a calculator, and I don't want you to draw pictures. I want you just to use what I would call fraction sense to figure this out. So let's say we have 3/8, 3/4, 3/10, and 3/2. Okay, and we're going to rank these smallest to largest. Okay, so notice the numerators are in fact the same, right? So we can go with our rule up here that says the bigger the denominator, the smaller the fraction. So the smallest fraction would actually be 3/10. Again, take our pizza example, right? If you split a pizza up into 10 slices and you ate 3 of them, those slices are going to be smaller than if you get 3 slices of an 8-slice pizza, okay? And then those pieces are going to be smaller than if you only split the pizza into 4 pieces. And then, of course, 3/2 is interesting, right? That's actually an improper fraction, so this is actually greater than 1. So 3/2 is certainly the biggest one because it's actually larger than 1. So as long as the numerators are the same, feel free to use the rule, the bigger the denominator, the smaller the fraction. So what about this? 2/5, 1/5, 4/5, and 5/5. Okay, so notice this, the denominators are all the same, right? So picture a pizza where we split that pie into 5 pieces, right? So if you didn't want a lot of pizza, maybe one of the slices would be enough, right? That's the smallest. If you're a little more hungry, 2/5. Super hungry, 4/5. And then if you're not going to share at all, right, because you're eating the whole thing, that would be 5/5. So if we have the numerators the same or the denominators the same, it's relatively easy to rank these from smallest to largest. But admittedly, that's not going to happen a whole lot. So another way to compare fractions is to use benchmarks. Benchmarks is simply using previous information to learn something new, or using something that's already kind of been established and comparing the new information to it. So with our fraction example, some of the first fractions we learn can really serve as our benchmarks a lot of times. So I'm going to call them kind of easy to understand examples. So I'm going to say easy to understand or remember. And the reason we like these is they're easy to compare to. Okay, so one of the biggest fraction benchmarks is 1/2. Okay, you'll find a lot of times we'll compare the fractions we have to 1/2 because, again, 1/2 is one of our benchmarks, right? It's one of the first fractions our students learn, and it's relatively easy to talk about compared with maybe some of the others. All right, so I want you to take out the developing fraction sense worksheet. Okay, so it looks like this. And we're just going to do a selected few of these. To be honest, you'll have to kind of fill in the blanks on the rest. It's not for homework, and the homework will be clearly marked, but I just sometimes go through worksheets with you where we don't do them all. So we'll go ahead and write some notes, but let's go ahead and say where we got this so you remember. So we're going to look at worksheet 5.8, developing fraction sense. So let's look at number 1. We're supposed to name a fraction between 1/6 and 2/6. Okay, and notice our issue is we don't have a whole number in between 1/6 and 2/6, right? So what we're going to want to do is we're not going to say 1.5 over 6. Okay, that's really complicated and we're not going to do that. But what we can do to try to squeeze maybe another value in between is we can increase the size of the denominator, and we do that through multiplication. So I'm going to choose to double the denominator, but when I do that I have to make sure I do the same thing to the top. Okay, by the way, this is allowed because I'm really just multiplying by 2 over 2, which is 1. Okay, same thing for this one. So notice what I'm going to get here. I'm going to get 2/12 here, and I'm going to get 4/12 here. So now I think we can go ahead and pick out something that's in between these, right? So if I want something in between, okay, what would be in between 2/12 and 4/12? 3/12. Okay. Now, it would be up to you as the teacher if you would have your students reduce that to 1/4. I'm always going to want you to give me the reduced answer, but honestly, when you were first teaching concepts of fractions, I might not have them reduce that. Okay. So the answer is 3/12 or 1/4 is between 1/6 and 2/6. I say the answer, but that's actually just one answer. Okay, I could have just as easily multiplied the denominator by 3 and done the same to the numerator, and then I would have had a completely different answer. Okay, so there's actually an infinite number of answers I can have here. Okay, so let's skip down to number 4 on the worksheet. Some of these are really, really similar, so I don't want to do a whole bunch of them. So it says name a fraction that is greater than 1/2, but closer to 1/2 than 5/8. Okay, so we have a little bit more stipulations on what we're doing this time. Okay, so notice we can try to just make the common denominator here. So if we multiplied by 4, then we're going to get 4/8, right? And we'll compare that to 5/8, right? I didn't have to change that one. Notice I run into a problem though, right? Because I don't have anything in between there, okay? And so just know that you can actually multiply by anything that you want as long as you do the same thing to the top and the bottom. And I'm not going to multiply by 2 because if you think about it, I'm going to get 8 over 16 and 10 over 16. And I'm only going to have one choice in that case, 9 over 16. And if you read number 4, it says name a function or fraction, that is greater than 1/2 but closer to 1/2 than it is to 5/8. And if I only multiply by 2, I'm not going to be able to achieve that. I'm only going to have one possibility. So I'm going to multiply by 3. Okay, and notice this is going to give me 12 24ths and 15 24ths. And notice now I have two options, right? I could pick 13 24ths or I could pick 14 24ths, right? So which one would I choose, because I want it to be closer to the 12 24ths? So we're going to pick 13 24ths. Okay, and the reason I picked that, of course, is because it is closer to 12 24ths or 1/2 than it is to 15 24ths or 5/8. Okay, so notice my explanation there. All right, so I want to do a couple from part B. You will probably see these again on possibly a homework and probably a test. So let's look at the same worksheet, not part B, sorry, but part 2. Okay, so notice part 1A. Okay, so this is going to be number 1A. I want you to place these as closer to 0, 1/2, or 1, and then talk about why it is the way it is. I'm just going to pick a couple of these and show you what I'm going to want to see here. Okay, so let's take the first one, 3/8. Okay, so the question is it closer to 0? Is it closer to 1/2? Or is it closer to 1? Okay, and you may have your guess. Okay, but let's change this so that we're comparing apples to apples. In other words, my denominator here is 8, so really the denominators that I'm comparing here need to be 8 as well. So how would you write 0 as something over 8? It would be 0 over 8. Okay, how would you write 1/2 as something over 8? It would be 4/8. And then 1 is always something over itself. So now we can really say what I would want to say here. So I'm going to kind of describe this. So now notice that 3/8 is clearly closer to 4/8, right? So 3/8 is closer to 4/8 or 1/2, right? Because 4/8 was just another representation of 1/2, okay? And here's where I want you to talk about why, okay? I don't want you to say pieces. I want you to say how many eighths away it is, okay? Because it is only 1/8 away from 4/8, but it is 3/8 away from 0/8, and then it's 5/8 away from 1. Okay. So honestly, this whole entire explanation is what I would want to see on homework or a test for that one. All right, so let's look at one more and then you can practice some of these on your own. Let's look at 1/3. All right, so the question again is, are we closer to 0? Are we closer to 1/2? Or are we closer to 1? So notice when we try to compare them, the 0 and the 1 are kind of easy, right? So we'll compare to 0/3, right? I'm going to leave that middle one blank. 1 would be 3/3. But notice this one's really a challenge, right? Like, what are you going to say 1/2 would be if you're talking about thirds? You can't say 1.5 over 3. Okay, our students would never get that. They would never talk like that. Okay, they would never put decimals and fractions if they could help it, probably. So we don't really have a pleasant denominator to talk about. So when you have an odd denominator, my suggestion to you is to go ahead and increase the size of it. And again, you do that through multiplication. So we're going to change it to 2/6. Okay, and so now let's instead compare it to something a little more pleasant. So instead we'll compare to 0/6, right? Now we can talk about a half pretty easily, right? How many sixths would it take to make a half? It would take 3 of them, right? Or 6/6. Okay, so remember 1/3 is 2/6, so is 2/6 closer to 0/6, 3/6, or 6/6? Okay, so it's closer to 3/6. So in the end, this is your explanation. You're going to say 1/3 is closer to 1/2 because it is 1/6 away from 3/6 or a half, but it is 2/6 away from 0. So we'll say 0/6 or 0. And then it is a full 4/6 away from 1. So I'm asking you to be pretty specific here. Okay, so again, this probably should be review if you took the class before this one at this university, but if you didn't, I'm showing you kind of what information I'm going to want to have there.